Hello and welcome back to our physics revision class. Today we are going to see Unit 3, which is about kinematics. So kinematics is simply a branch of mechanics that studies motion without being concerned about its cause, okay? So in this unit we have two main parts. The first one is motion along a straight line or rectilinear motion, or we can call it motion in one dimension. And the second part is about motion in a plane, curvilinear motion or motion in two dimension, okay? So generally motion is defined as a continuous change in position of an object with respect to some reference frame. You know that reference frame is a point or a coordinate system from which we observe and measure the motion of objects. So in general, motion can be classified into two, like uniform motion and accelerated motion. Accelerated motion by itself can be classified into two, uniformly accelerated motion and non-uniformly accelerated motion, okay? So an object is said to have a uniform motion if it covers equal interval of distances in equal interval of time, okay? In equal interval of time. Or in other words, objects are said to have a uniform motion or uniform motions if they are moving with a constant velocity, okay, without their velocity being changed. On the other hand, if the velocity of the objects is changing continuously with time, then we say the motion is accelerated motion, okay, accelerated motion. So accelerated motion, like we said earlier, can be classified into two, non-uniformly accelerated motion and uniformly accelerated motion. If the velocity of objects is changing continuously with time at a fixed rate, then it's called uniformly accelerated motion. But if the velocity is changing in an irregular pattern, then it's called non-uniformly accelerated motion. You know that acceleration is simply refers to change in velocity, okay? All right, so in a uniformly accelerated motion, we have these 5 important questions. So there is one more left here. This is final velocity is equal to initial velocity plus a times t. We can have also v final is equal to initial velocity plus or minus g times t, okay? So uniformly accelerated motion, acceleration is considered as constant. So if an object is in uniformly accelerated motion, so we can use these equations of motion to describe the different properties of the object. We can determine its distance after it has traveled with at some time t, or we can also use this expression to determine the displacement or the distance of the object. And all these are equally important. Which one should we use depends on our given and requirement, okay? So a typical example of uniformly accelerated motion is a free fall. So an object in air which is subjected to only gravity is said to have a freely falling motion. So since the only force acting on the object is gravity, and the objects which are subject to gravity accelerate at a constant amount of 9.8 meters per second square, then we consider free fall as example of uniformly accelerated motion. So these equations that we have derived for uniformly accelerated motion will also hold true for free fall with a slight modification. Here we have used s, but we're gonna use h to show a vertical height. So h is equal to initial velocity plus final velocity times time divided by 2, and all these are very useful in determining the motion of a free fall, okay? But as you can see, we have used here plus or minus. This is because an object may go up or down. So if the object is moved against gravity, so if it's an upward motion, so g is negative. So for mathematical simplicity, we usually use 10 meters per second square. But if the object is moving downward, since it's moving towards the gravitational pull of the earth, then we consider g as 10 meters per second square. That's positive, okay? So the second part of kinematics is motion in a plane or two-dimensional motion. So there are two important examples of motion on a plane. The first one is a projectile. So a projectile can be defined as an object in air after being thrown either horizontally or vertically or at an angle. So if the only force acting on it is gravity, then the motion is called a projectile motion, okay? So you can see here we are considering an inclined projectile motion. So initially the object is launched with initial velocity v, making an angle theta with the horizontal. So as a vector, the velocity can be decomposed into two components. We have the horizontal component v cos theta and the vertical component v sin theta. So we can consider this kind of projectile motion as a combination of two simultaneously happening motion, okay? The horizontal motion and the vertical motion. And these two motions are independent of each other, okay? So since they are independent of each other, we can consider them separately. So we can consider the horizontal motion by these two equations. The horizontal displacement after some time t, when the object reaches this position, x is given by initial velocity along the x, v naught cos theta times t. And the final velocity vx is equal to v naught cos theta. This, as you can see, the horizontal component of the velocity of the object remains constant for the whole journey of the object, because this is because the only force acting on the object while it's on air is gravity, and we know that gravity is a vertical force. So since there is no force acting on an object in the horizontal direction, there is no horizontal acceleration. If there is no horizontal acceleration, then the velocity of the object along the horizontal direction continues to be constant, okay? So when we consider the vertical motion of the object can be expressed using these three equations. Y can be expressed v naught sin theta minus half gt square. As you can see, we have used a minus sign here. This is because initially the object is moving in the upward direction. That's against gravity. That's why we use negative here, okay? So these three are equations that express the vertical motion of the object. So in addition to these equations, we can also have equation for the maximum height attained by the projectile, the time of flight, the time that the object takes to complete the whole journey, and the range. The range is the maximum horizontal displacement of the object, okay? So the maximum height, h max, is given by v naught square sin square theta over 2g. So as you can see from this mathematical expression, the maximum possible height that an object can attain is when theta is equal to 90 degrees. So that when the object is projected vertically upward, okay? When theta is 90 degree. So time of flight can be calculated using this mathematical expression, 2 times v naught sin theta over g. That is the time the object takes to travel from this point to this point, okay? And we have the range. The range is the maximum horizontal displacement. We have said that. So the range can be expressed using these two mathematical expressions, 2 times v naught square sin theta cos theta. But we know that from trigonometry, 2 times sin theta cos theta is sin theta. So we have an alternative way to express the range. R is equal to v naught square sin 2 theta over g. So using this mathematical expressions, we can analyze what we call projectile motion, okay? So another example for motion in a plane is uniform circular motion. So an object is said to have a uniform circular motion if it is rotating on a circular path with a constant speed, okay? If it's rotating on a circular path with a constant speed. So even though the speed of the object is constant, since the direction of motion of the object is continuously changing with time, we say the object is still accelerating, okay? For example, when the object is reaching at this point, this is the direction of the velocity. When it's here, this is the velocity direction. As you can see, the direction of motion of the object is changing continuously with time, all right? So as a result, there is an acceleration, because acceleration implies any change in the velocity of the object. So you can see that the acceleration, the acceleration of objects due to a continuous change in this circular path is called centripetal acceleration. So the mathematical expression for the centripetal acceleration is given by A centripetal is equal to v square over r, okay? So the force, if there is an acceleration, there must be some kind of force which is responsible for it. The force which is responsible for the centripetal acceleration of the object is called centripetal force. So the centripetal force is given by, according to Newton's second law, force of centripetal is equal to mass times centripetal acceleration. And we know that the centripetal acceleration is v square over r. So the centripetal force is given by mv square over r, okay? So as their name indicates, both the direction of the centripetal acceleration and the centripetal force is towards the center of the circular path, Okay. So next topic is about relative velocity. So generally motion in physics is considered as relative because it depends on our reference frame. As you remember, we have defined reference frame as the point or the coordinate system from which we measure the motion of objects. We observe and measure the motion of objects. So relative velocity is the velocity of objects in one reference frame as compared to another one. Okay. For example, you can consider two cars. So there is observer 1 here, observer 2 here. This is A, and this is another observer B here. Okay. So observer 1 is measuring VA and VB, but the relative velocity of observer A as observed by in B is equal to VA minus VB. Okay, this is read as relative velocity of A with respect to B, or the velocity of A as observed by B. Okay, so the relative velocity of A with respect to B is equal to VA minus VB. Okay, you can use this to determine relative velocities. So this is all about kinematics. I hope again you find this very useful, and I hope you will do some practical examples on them. So until next time, stay safe.